Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the chapter chemical bonding. Okay, in this session let us see about the electronic theory of valency, which was explained by Kossel and Lewis to understand about the chemical bond formation by different elements. There were number of attempts to explain the chemical bond formation between atoms in terms of electrons, but a satisfactory explanation for this concept was given by Kossel and Lewis in 1916. So even though there are many attempts were given by different scientists to explain the concept of chemical bond, but in those, one of them is the satisfactory explanation was given by Kossel and Lewis in 1916, which gave more clarity about the stability and the chemical bond formation of atoms. They gave this concept independently. The basis for their theory was valence in terms of electrons. What is meant by valence here? And the valence electrons. So these two they have taken as a standard to explain the stability of different atoms and the tendency to form chemical bonding by the atoms. So here the electrons present in the valence shell of an element are considered as the responsible for chemical bond formation. The electrons present in the outermost shell of an atom are called as its valence electrons. And the tendency by an atom to become stable. In the tendency, some elements they gain electrons, some they lose electrons, and even some other elements they will share electrons with other atoms. There the number of electrons gained, lost or shared by an element to become stable is called its valency. So based upon this valency, the stability and the chemical reactivity of elements were explained by Kossel and Lewis. They provided logical explanation of valence on the basis of the lack of chemical activity of noble gases, which led to the proposal of octet rule. So they have studied the electronic configurations of these noble gases, which we are calling as stable elements. They are not at all participating in the bond formation. So they have studied these electronic configurations of these noble gases, and there they understood why those elements are being highly unstable and least reactive. So based upon that, they have given the proposal octet rule. Observe the practical behavior of atoms of main group elements, first A, second A, third A, all subgroup A elements, 1A to 8th A, which we call as zero group elements. When they are allowed to undergo chemical changes, they try to get octet electron configuration in the outer shells. Octet electron configuration means getting 8 electrons in the outermost shell. Here oct represents 8. Getting 8 electrons in the outermost shell is giving extra stability to the atoms. They become least reactive and high stable by having 8 electrons in the outermost shell. That configuration with the 8 electrons in the outermost shell is called octet electronic configuration. The elements of these all groups from 1A to 7A, these all elements, if they undergo chemical changes, they will try to get this octet electronic configuration in their outermost shells. Let us understand this with the following illustrations. Let us see one by one all the groups. If you see about 1A group elements, which we call as alkali metals, isn't it? The first group of this periodic table containing elements lithium, sodium, potassium, rubidium, cesium and francium. These elements are called alkali metals. So if you observe the electronic configuration of these elements, they have only one electron in their outermost shell, isn't it? If you say lithium, its atomic number is 3 and its configuration will be 2, 1, means in the outermost shell lithium is having only one electron. In the same way, if you see sodium, what is the atomic number of sodium? It is 11, and its configuration will be 2, 8, 1. Means sodium also has only one electron in its outermost shell. In this way, all the 1A group elements, they are having only one electron in their outermost shell. So these 1A group elements will try to lose one valence shell electron from their atoms to form corresponding unipositive ions, which get octet in their outermost shell. So by losing one electron, they will get octet configuration of the nearest noble gas. For example, if you see sodium, we know sodium configuration is 2, 8, 1. Means in the outermost shell, it has only one electron. If it loses this electron, now its configuration becomes 2, 8, which is a stable electronic configuration of nearest noble gas neon. So when it is allowed to participate in the chemical reactions, sodium will lose one electron and it gets a octet configuration of nearest noble gas neon. Okay, in this way, not only sodium, from this group, 1A group, all the elements, they will tend to lose one electron always, and hence they get a nearest noble gas configuration. Okay, next, if we observe the second A group elements, which we call as alkaline earth metals, beryllium, magnesium, calcium, strontium and barium. These second A group elements are called alkaline earth metals. If you observe the electronic configuration of these elements, they are having 2 electrons in their valence shell. For example, if you see magnesium, its atomic number is 12 and its configuration will be 2, 8, 2. In the last shell, it has 2 electrons. So that will be when it is allowed to participate in the chemical reactions, that will try to lose those 2 electrons and gets the octet configuration of nearest noble gas to it, that is neon. Not only magnesium, in this way group 2A elements try to lose 2 electrons from its valence shell of their atoms during the chemical changes, and they form dipositive ions with the octet in the outermost shells. In that way, by losing of 2 electrons, they will get a octet configuration in their outermost shells. That means the nearest noble gas configuration. Let us see one example. From this group, if you consider magnesium, we know magnesium atomic number is 12 and its configuration 2, 8, 2. If you observe here, there are 2 electrons in its outermost shell. So as there are 2 electrons in the outermost shell, it is not a stable element, isn't it? To be stable, just like the noble gases, that element should have 8 electrons in its outermost shell, but it has only here 2 electrons. Now if it is allowed to participate in the chemical reactions, it will readily lose these 2 electrons. By losing of these 2 electrons, it is getting this 2, 8 stable octet configuration of nearest noble gas neon. Okay. Now in this way, these second A group elements will be ready to lose 2 electrons whenever they are allowed to participate in the chemical reactions. They lose these 2 electrons from their valence shell, and hence they attain the stable octet configuration in their outermost shells. Okay, and hence they form dipositive ions, dipositive anion, cations we call these. Dipositive ions are being formed by second A group elements. Next one, if you observe third A group elements, these third A group elements will try to lose 3 valence electrons from their atoms, so and form corresponding tripositive ions with the octets in their outermost shells. Okay, so by losing of 3 electrons, these third A group elements, they will attain the octet configuration of nearest noble gas to them. Let us consider one example here also. So third A group elements are boron, aluminium, gallium, indium and thallium. If you observe one of those elements, aluminium, its atomic number is 13. If we write electronic configuration for that, we get it as 2, 8, 3. Means these elements of third A group are having 3 electrons in their valence shell. as they are having 3 electrons. Are these elements stable elements? No, not at all, because they are not having 8 electrons. They have only 3 electrons in their outermost shell. Hence, when they are allowed to participate in the chemical reactions, these will be ready to lose 3 electrons. And they lose these 3 electrons, and hence they will get the nearest noble gas octet configuration. And thus they form tripositive cations or tripositive ions. So third year group elements will be ready to lose 3 electrons and form tripositive ions, and hence they get octet configuration of nearest noble gases. Okay, let us consider some other elements from 6th year group, those which we call as chalcogens, oxygen family. We can say oxygen, sulfur, selenium and tellurium. These elements will be having 6 electrons in their outermost shell. As there are 6 electrons in their outermost shell, if they gain 2 more electrons, 2 more extra electrons, they can get octet configuration in their outermost shells. That is why these 6th A group elements will try to gain 2 electrons into their valency shell of the atoms during the chemical changes and form corresponding di-negative anions, which get octet in their outermost shells. Okay, by gaining of 2 electrons, they get the octet configuration of the nearest noble gases. So that's why they form di-negative anions in the chemical changes by gaining 2 electrons. Let us consider one of the 6th A group elements, oxygen. Its atomic number is 8, as we know, isn't it? So when it is allowed to participate in the chemical reactions, it will be ready to gain 2 electrons. It gains 2 electrons and it attains a configuration. Sorry, it is not there. By mistake it has given. Okay. Now the configuration of oxygen is 2,6. It has only 6 electrons in its valency shell. By gaining 2 more electrons, it can get nearest noble gas configuration 2,8. So when it is allowed to participate in the chemical reactions, oxygen will gain 2 electrons and thus it will get a stable octet configuration in its outermost shell, and it forms di-negative anion. O-2 will be formed. Okay. In this way, 6th A group elements will be ready to gain 2 electrons into their valency shells to complete its octet. Next, if we observe 7th A group elements, which we call as halogens. Did you remember what are 7th A group elements? They are fluorine, chlorine, bromine, iodine and astatine. These elements are having 7 electrons in their outermost shell. For example, if you see fluorine, the atomic number of fluorine is 9, and if you write its configuration, we get it as 2,7. Means in its outermost shell, it has only 7 electrons. So how many electrons are required still to become stable with octet configuration? Only 1 more electron. So when these 7th A group elements participate in the chemical reactions, they try to gain 1 electron into the valency shell of their atoms during the chemical changes and form corresponding uni-negative anions, which get octet in their outer shells. Okay, by gaining of 1 electron, these elements will form uni-negative anions and thus they will get octet configuration into their valency shells, and those atoms become stable with octet. For example, if you see fluorine, just now we told, it has configuration 2,7 and hence it gains 1 electron to get the stable octet configuration 2,8. Okay, in this way 7th A group elements will gain 1 electron and form uni-negative anions to attain the octet configuration. Now let us observe the 8th A group elements. Group 8A elements, which we call as noble gases or ideal gases. The noble gases do not try to lose or gain electrons because they already have 8 electrons in their outermost shell, need not to participate in the chemical reactions, need not to lose or gain electrons because they have already the required number of electrons for stability. So the noble gases do not try to lose or gain electrons. Generally, helium and neon, they do not participate in the chemical changes at all. Actually, we say these noble gases, they do not participate in the chemical reactions at normal conditions, but by altering the conditions to high range, the heavier elements among them like xenon, these elements may participate in the chemical bonding at abnormal conditions. So generally helium and neon, they do not participate in the chemical changes. In other elements of VIIIA group also, they do not gain or lose electrons from their atoms when they participate in a very low or a very few chemical changes. Okay, some of these VIIIA group elements at a certain different conditions, they may participate in the chemical changes. For example, xenon reacts with highly electronegative element fluorine to form xenon fluoride. There also they do not lose or gain electrons, just they share electrons. So because there is no necessity for these VIIIA group elements for losing or gaining electrons, because they already have sufficient number of electrons in their valence shell. That means they have already 8 electrons in the outermost shell. Okay. For example, if you see neon, what is the atomic number of neon? It is 10. If you write configuration, we get it as 2, 8. So in the valence shell or in the outermost shell, neon is having 8 electrons in its octet, or it has octet in its outermost shell. So no electrons gain or loss from the neon atom. It won't participate in the chemical reactions, that is why. Noble gases of VIIIA group possess 8 electrons in the valence shell of their atoms. Okay, of course it is an exception for helium. All the elements except helium from the VIIIA group, they possess 8 electrons in their valence shell. What are those VIIIA group elements? Helium, neon, argon, krypton, xenon and radon. These all elements, they have 8 electrons in their outermost shell except helium. Its atom has only 2 electrons. Helium has only 2 electrons, isn't it? Because its atomic number is 2. It has only 2 electrons, but its only one shell is completely filled. It has only one shell that is completely filled with 2 electrons. That is why it is also being stable as the remaining elements from this VIIIA group, even though it is not having octet. The configuration of this helium with only one shell that is completely filled with 2 electrons is called duplet configuration. Okay. Noble gases with 8 electrons in the valence shell in their atoms are highly stable and rarely participate in the chemical changes. Generally, at normal conditions, these noble gases, they do not participate in the chemical reactions. With highly reactive elements at certain different conditions, they may participate in the chemical bonding. Then also they neither gain electrons nor lose electrons, just they share electrons with other atoms. Okay. Therefore, it is concluded that any species with 8 electrons in the valence shell is being stable. Okay. They found finally, based upon these electronic configurations of noble gases and their unreactivity, by studying these concepts, they came to one conclusion that atoms are species. So here species represents either atoms or ions, which are having 8 electrons in their valence shell are being more stable. Okay. So first A group elements to 7th A main group, these all elements during chemical reactions get 8 electrons in their outermost shell of their atoms or ions, similar to noble gas atoms. So this may be happened either by gaining of electrons or losing of electrons by these atoms. Finally, by formation of ions, they get octet or 8 electrons in the outermost shell. 8 electrons in the outermost shell gives stability to the ion or atom. So based upon these all above observations, a statement known as the octet rule is framed. Let us see what is this octet rule here. It may be stated as the atoms of elements tend to undergo chemical changes that help to leave their atoms with 8 outer shell electrons. So always the elements will tend to undergo chemical changes. By that they will get 8 electrons into their outermost shells and hence they become stable. So that is octet rule. The tendency of atoms trying to get 8 electrons into their outermost shells by participating in the chemical reactions is called octet rule. By having 8 electrons in their outermost shell, atoms become stable. So Lewis depicted the atom in terms of a positively charged kernel and outer shell that could accommodate a maximum of 8 electrons. So Kossel, he has proposed that atom has a positively charged kernel, means the nucleus and the electrons around it completely he considered as a kernel except the outermost shell. So this kernel is surrounded with one outermost shell which could accommodate a maximum of 8 electrons. Even though its capacity is more than 8, the outermost shell of an atom will be having only maximum of 8 electrons. The atoms with 8 electrons in the outermost shell are being more stable, and those which are not having 8 electrons in the outermost shells will participate in the chemical bonding to get 8 electrons. Chemically active elements do not have an octet of electrons in the valence shell of their atoms. So the atoms which are not having 8 electrons in the valence shell, they are being chemically active. They are not stable. They will be active elements. Their reactivity arises from their tendency to achieve the octet by forming bonds either with atoms of their own type or with the atoms of another elements. They will try to get a octet in their valence shell. The force of attraction between any two atoms or a group of atoms that results a stable entity is called a chemical bond. There are many types of chemical bonds. Now let us discuss about a few of them like ionic bond, covalent bond, etc. For example, if you consider sodium with atomic number 11 will readily lose one electron to attain neon's stable electron configuration, isn't it? It has only one electron in its outermost shell, so by losing that it will get the neon configuration. Similarly, if you observe chlorine has electron configuration 2, 8, 7. So to get the nearest noble gas configuration, it gains one electron, so that it gets the argon configuration. So chlorine readily gains one electron from the other atom and obtains stable electronic configuration. Right? Thus elements tend to have stable valence shell either by losing or by gaining electrons. But here we may get one doubt. Which atoms tend to lose electrons and which atoms tend to gain electrons? Generally, the atoms with 1, 2 or 3 electrons in their valence shell, they tend to lose electrons, whereas the atoms having 5, 6 or 7 electrons in their valence shell, they tend to gain electrons and hence they get octet configuration. If you observe boron, its atomic number is 5 and its configuration is 2, 3. So as it is having 3 electrons in its valence shell, it may lose these 3 electrons to become stable like helium. If you observe nitrogen, what is the atomic number of nitrogen? It is 7. If you write configuration, we get it as like this, 2, 5. Now as there are 3 electrons in its valence shell, its valence electrons are 5. So as valence electrons are 5, it will be ready to gain electrons from other atoms. How many electrons are needed still? It needs 3 more electrons, so that it will get 8 electrons in the outermost shell. So nitrogen will be ready to gain 3 electrons. It will tend to gain electrons. What about oxygen? Its atomic number is 8 and its configuration if we see 2, 6. And as it has 6 electrons in its outermost shell, it will be ready to gain 2 more electrons. It tends to gain electrons. And if you see sodium, atomic number is 11 and its configuration is 2, 8, 1. And it has only 1 electron in its valence shell, thus it tend to lose this 1 electron. So in this way, the atoms with 1 or 2 or 3 electrons in their valence shell tend to lose those electrons, and hence they get nearest noble gas configuration. And the atoms with 5 or 6 or 7 electrons in their valence shell tend to gain electrons, and hence they get octet configuration. Okay, that's about electron theory of valency. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates on recorded videos.